So I'll give you a little bit of background about who I am, because I wear a lot of different hats. I've spent about 8 years in the enterprise security, application security world, starting out down in the trenches of code review, and I've increasingly moved up into architecture and threat modeling and security engineering work. About 4 years ago, I jumped over and started doing more work with NGOs and news organizations targeted by nation states. And I realized when I started dealing with people who had actual problems and had actual attackers that we don't actually know very much about security. We are far less able to deal with security in the real world than we think we are. And it's been a few years of kind of dealing with that realization and starting to figure out how to fix it. And where I am now is kind of starting to be the result of that. So we have this idea that computer security is about computers. It's not. Computers have actually relatively little to do with what our job is. So many, many years ago, people started building computers because they had work that they needed to do and to get done. And then they started building more computers and they started networking them because they needed to get more work done. And at a certain point, these computers started getting compromised. And then folks decided, well, let's pay these people to fix this problem. And we made a little mistake there. We thought that they meant that we should go fix the computers. That was not what they needed. Having made this mistake of thinking that we were supposed to fix computers, we built an entire industry around the wrong problem of fixing computers. People built yet more computers and yet more networks, and we started realizing from this perspective of trying to fix the wrong problem that we couldn't secure them all individually. And now we're at where we are now, where we're starting to look at, large data analysis, looking at populations of machines, starting to look finally at epidemiological approaches. Basically, how do we scale fixing the wrong problem? We never fixed the right problem. Security is the set of activities that reduce the likelihood of a set of adversaries successfully frustrating the goals of a set of users. You'll notice that nowhere in this definition does it say anything about computers, because security does not have anything to do with computers. It has to do with the things that people are trying to accomplish in the real world. The ability to define and determine what a technical system will and will not do is necessary, but not sufficient to determine whether that system is secure. So if you can determine all of the code paths that a system will take in response to execution, both all of the intentional ones and all of the weird machines that got built into it, you still don't know whether that system is secure. Because if you want to understand whether it's secure or not, you have to understand what people are trying to use it to do. The mismatch between a set of human goals and a set of executing code is where almost all of the bugs that actually matter lie, right? Does this, can I compromise this Android device at a very low level? That's interesting, but that's not actually the problem that a user of that system has. The problem of a user that system has is I need this system to maintain certain invariants as I work. One of those invariants might be confidentiality of data, various other things. So this leaves us with basically a missing field within security. Security design is the process of understanding user culture, goals, and workflows, organizational technical capabilities, and adversary capabilities and dispositions, and synthesizing a solution to this problem, right? So we start off with not actually even the goals of the user, but the culture of the user. How do users work? If you have a group of people who you are trying to provide security support for, whether that's the user base of a Fortune 500 company, or all of the customers of a major bank, or these 4 journalists in some godforsaken country who are trying to not get killed, you need to understand the ways in which they work, the ways in which trust flows, the ways in which those teams interact, the ways in which, you know, let's say you're talking about banking customers. Do your banking customers own their own machines? Are they mostly working from mobile devices? Are those mobile devices shared, right? These are basic questions about the culture of their interaction with their computers that you're not going to be able to functionally accomplish security without understanding, but it goes deeper than that. You know, do bank accounts represent a single family? Okay, that implies certain things about authentication systems. Do they represent, groups? Okay, that implies a very different thing about authentication systems. So it starts there, and then you start looking at the goals, and then you start looking at how people work. And now you maybe know enough about your users to be able to say something meaningful about their problems and what they want. You have to understand, obviously, the capabilities, what you can field on your side, what you can actually build. And then you have to understand what your adversaries can do and what they want to do. And what they want to do is almost certainly much more interesting than what they can do, right? Because that's where you say, okay, if our adversaries are malware writers, are malware authors who are looking to write banking Trojans, so they have some very specific goals. And those goals are not necessarily just simple financial transactions. There's a lot of nuance and complexity there that's going to shape the responses that they take and is going to shape whether or not your countermeasures are useful. One of the things that working in the field taught me is that outcomes are messy. So we have this idea that assurance is a goal for security organizations, right? That you want to provide an enterprise with assurance that the systems that they operate will not get compromised. It turns out that, especially when you're dealing with high-risk users or people who are specifically targeted, assurance is kind of a joke, right? If you're dealing with journalists who may get killed for the reporting work they're doing, sometimes you just get unlucky. And we have this idea that we can provide more guarantees than we are actually capable of doing. And this goal of assurance, which is basically something that's coming out of, and I say this as a consultant, is coming out of consulting marketing material, right? It's ridiculous. We can't actually do it, but we've built this culture around it. So now we promise it, even though we know we can't deliver it. And it prevents us from acknowledging the fact that all of the systems we interact with are categorically broken. They're basically just piles of bugs built on top of each other and the hope that they'll in some way be structural. And it also, because we're only willing to evaluate solutions that give us assurance, it limits radically the kinds of mitigations we're willing to look at. For instance, one of the really useful tools, if you're looking at end user security systems, is you've got this really great pattern matching processor connected to that system. It's called the user. The user actually has a pretty good idea at any point in time what things their system should probably be doing. So if you can give the user more feedback about what their system is actually doing, you can then give them ways to react. Not technically, they're not going to say, oh, I better reinstall this operating system, but they may say, oh, it looks like this thing is telling me that this machine is transmitting audio when I don't think it should be. Maybe I'm just going to close that machine and leave it out of the room, or it gives them ways to adapt, right? And is that adaptation going to be perfect? Is the user going to recognize this all the time? No, of course not. But that doesn't matter because we're not going for assurance. What we're going for is improvement in outcomes, statistical improvement in outcomes over time. So, as I said, I learned a lot about the things we don't know and about this process by working with users who have actual problems. One of the core things there is that if you don't understand how your users plan for and think around security, you can't help them. Now, if your users are not targeted, if they're not at significant risk, maybe they don't think about security. Certainly, maybe they don't think about security as much as all of us whose, hobbies or lives are thinking about security would like. But there is still a planning process that happens. And when you're working with people who are targeted and are aware they're targeted, that planning process becomes more obvious. And so it's easier to study and then understand how that shifts over. So the general kind of structure of the task is planning in the presence of an adversary. And there's literature in various contexts here. Unsurprisingly, various militaries have a lot to say about this stuff, although their planning processes are more heavyweight than you can possibly imagine. But there's one really useful thing that came out of that. There's a guy named John Boyd, who's a US Air Force colonel, and he came up with this thing called an OODA loop. And this was, would have been in the 50s. And this was kind of one of the first structural representations of a planning process in the presence of an adversary. And so an OODA loop, I'm going to jump forward here. An OODA loop is the core of this process, right? Observe, orient, act, decide, act. Observe the world around you. Orient yourself within the possible actions that you can take. Decide on an action, implement it, go back to observing. Right, that's the core, and you can shift that around depending on exactly how you want to divide up the steps. But that's the core of every oppositional planning process. There is a notion of turning inside your adversary's OODA loop. The idea that if you and your adversary are both trying to plan your reactions, if you can plan more quickly than them at the same depth, you will end up all else being equal, which it isn't, but if it were equal, you will end up basically being able to outplan them and winning the conflict. So one of the things that this brings us to is cognitive overhead. So if you are trying to build security, trying to design security countermeasures or security tools for your users, and they are complex tools, they require a lot of thinking about how they're going to be deployed, chances are you are actively hurting their security outcomes because you are absorbing all of the space in their planning process, thinking about your tool. So they're either going to decide they don't have time for it, misuse it, or shortcut all of the other things. And there's a whole list of stuff around that circle, all of the different task domains that that those users need to be thinking about, of which, like digital security practices for any real process is just one tiny little thing. So operational utility and functional deployability are the two other things that come out of the operations process. If you don't have a very good idea of whether or not the system that you're building is going to support user goals and let them get more done, chances are it's not useful. And that is not a question of, is it going to keep them from being owned? It's a question of, are they going to get more work done? When we talk about security, a lot of what we're talking about really is efficacy. Because remember our definition at the beginning, it's about whether or not the adversaries can frustrate the goals of the users. Can they stop those users from getting that thing done? Making them spend all of their time thinking about security systems is a very effective way to stop them from getting anything done. This is the worse is better mantra, right? In many cases, if a system is technically less secure, but functionally lets a user get that much more work done, it is a better system from an efficacy perspective and from an outcomes perspective, because the user's goals are to get work done at an acceptable risk and an acceptable cost, not to maintain perfect security. We as security professionals are responsible for helping them maximize their goals, not the goals that we think they should have. So functional deployability is another interesting one. This is culture match. This is context match. Does this tool give them the things that they need to work in a specific place? The number of times we've seen systems which in theory are really secure, but in practice require things on the ground that none of the relevant users have. This is why Johnny can't encrypt. This is much of the story of end user facing security tools, and the same process repeats in the enterprise, just with much bigger checks attached to it. So invariants are one of the tools that we use to think about this stuff. So this is kind of the set of invariants that you guys are probably familiar with seeing. The idea of an invariant is this is something that you may wish to preserve in the operation of a system to varying degrees and with varying resource commitments, right? So, I want to preserve availability within the system, and I'm willing to, I want, this many nines of uptime, and I'm willing to spend this much money to get it. The same, I need to preserve integrity, and I'm willing to spend this much money. I need to preserve interoperability, and I'm willing to spend this much money. Now, in this case, we don't think of that as as like an uptime metric, as, oh, you're going to have failover interoperability systems. Well, except when you've got a massive enterprise deployment, and it turns out that when you try to get it working in production, it doesn't work, and you roll back, right? That is interoperability failover. We just don't think of it in those terms. It's the same kind of invariant. It turns out there's a lot of invariants that you may want to preserve. Here's a list of a few of them. The design of invariants has a lot to do with cognitive overload, right? Everything on this list that you try to give users tools to preserve or to change the structure of, they have to take into account in their planning process. You also have to make it legible to them. They have to be able to understand what the tools they have available to them, or they can't plan with them. Now, if we're talking about users who are not at specific risk, who are not targeted, or who are not aware that they're targeted, legibility can become less important because, maybe, oh, you get confidentiality for free, and it doesn't matter if you don't know about it, you still sort of get the benefit. Except in almost every case where you have illegible invariants, the user is going to act as though the system was less secure, right? If they're aware that there might be a problem and they don't know that this system can help them, then they're going to, trust their e-commerce merchants less, or whatever, whatever the specific case is. So even for users who aren't targeted, if they don't understand the ways in which the system can help them, you are doing them a disservice, and you are hurting their ability to accomplish their goals. So if we say that this is a design process, what does design mean? And we'll talk about what security design means specifically. So if you are going to design anything, right, you need to understand and document what the constraints are and what the capabilities are, right? You have to understand the problem. You also have to be able to tell people about the problem. If you're looking at a software development lifecycle, you're looking at, kind of your front-loaded requirements work. If you can't communicate to business drivers, this is why we need to deploy TLS 1.2 in this context, then you are unlikely to get the budget for testing or for devs or for whatever you need. What we're talking about here is up a few levels, though. This is looking at what are the requirements for this system? What are the tasks that we intend this system to support, right? So synthesize and validate potential solutions, so we think we have an understanding of what might work. Does it actually work? Justify them, support the development process, and prevent drift, where somebody further down the line says, well, we don't actually have time for, I don't know, doing any encryption whatsoever. The number of times I've seen key security features pulled out because, oh, the schedule, So when we talk about security design, I'm at least talking specifically about participatory design, and I'm actually going to jump ahead a few slides, and we'll come back to it because I want to situate this a bit better. So this is a development stack. You have requirements, you have architectural design, development testing, operations, Let's pretend it's a nice waterfall. It isn't. But And so when we think normally about security operations through the stack, you've got architectural analysis, you've got standards and frameworks for working with the developers so they build more secure solutions. You've got security testing, which is where a lot of us spend a lot of our time, and then you've got monitoring and incident response and patching and all the other kind of operations stuff. So at the core of a lot of thinking about security and requirements is threat modeling, right? So threat modeling done correctly drives most of your SDLC. Threat modeling and security architectural analysis heavily overlap. They're basically 90% the same task. It specifies, it drives your specs for what security requirement or what things need to be maintained during the development process. It drives testing because you now have a list of everything that can go wrong if you have a proper threat model. And it's a reference document for monitoring and incident response. When you're talking about security design, we add on to that an adversary modeling stage, which a lot of us skip because we think we understand who our attackers are. So you spend some time and actually understand what the problem is. And then we bring in this participatory design and security design steps up front. And this is where we figure out, are we actually designing the system that is going to provide users with the things that they need? So the difference with participatory design and the reason that we care is that security, the goals that users have are often not obvious, right? If you're designing Skype, what are the use cases for Skype? What are the goals that users have for Skype? How much is confidentiality important? In what cases is it important? What does confidentiality mean? Again, the narrower the deployment scenario, the better an idea you're going to have of this. One of the really interesting things that came up supporting some folks in Syria was that given the option of secure text chat tools that we could say fairly strongly weren't going to be intercepted, assuming they didn't have malware on their machines, et cetera, and that could provide metadata protection, et cetera, they were much more interested in continuing to use Skype because it gave them video. And this didn't make any sense to a lot of people. And like, why do these people, and it wasn't a question of training or anything else. And it turned out that one of the first things you do when you started a Skype call is you'd take the laptop up and you'd show the whole room. And you'd prove to them that there was nobody standing in the corner with a gun pointed at you telling you what to say. And that ability to surface, to basically do remote attestation of some degree of non-coercion in a conversation was much more important than security, than confidentiality or integrity in that context. So this is the kind of thing where if you don't actually know your users and know their culture and know the things that are that they're actually worried about, it's very difficult to do these kinds of design tasks. What we've seen in the field is that basically the only way to do that is to actually bring users into the product design process directly and into the security design process directly. Now, the security design process starts a lot earlier than a lot of people think. It is at the requirement stage, but that's also, okay, so you're going to deploy a bunch of cryptographic protocols that's just, that's just a base layer. Clearly, that's not part of security design. Well, the set of invariants that you're deploying is determined at the protocol level, right? So if you don't have users in the room when you're starting to think about the invariants that you want to have supported in your cryptographic protocols, you are already too late. One of the slides that I don't have in here, there's this great curve of cost, of what does it cost to fix a bug. And it's an exponential curve. And the cost to fix, so it's basically from time of introduction to time of fix. And if you've got a requirements level bug that you have to fix in deployment, it costs at least 100 times more to fix it. Something that would have been at the early requirements stage, literally oh no, we can't do that because X, probably just a conversation at most, a couple rounds in a Word doc, can become, in one case, axing an entire corporate division and firing everyone involved because it turned out that the product that the company was trying to deploy was fundamentally unsecurable and had fundamentally conflicting requirements. If you have to do cryptographic protocol redevelopment, it's probably even more expensive than that, because now you're not just talking about one product, you're talking about multiple products and standards processes, and it becomes nightmarish. So if you want to do security design in a meaningful way, it has to be participatory. Participatory design means recognizing users as authorities on their goals. So instead of assuming that you know what they want, bring them in, work with them to describe the things that they're trying to optimize for. It means that kind of deep cultural engagement that would let you see, oh, right, this is why these guys care more about video than they care about confidentiality. Users, really everyone, is horrible at telling people what they know and how they know it, especially when you're talking about group operations or communities and community support for each other. So working with users over time lets you surface that kind of tacit and embodied knowledge that is often really critical to operational outcomes. Knowing, for instance, yes, this is a chat system, but a lot of the work that's happening over it is arranging financial transfers. Okay, what is the tacit knowledge around financial transfers? It's not just that it needs to be confidential. Building long-term community trust. This is critical if you are in a scenario where you cannot simply force your users to use whatever it is you provide to them. And even if you think you can force your users to use whatever it is you provide to them, you're probably wrong, unless you're in the military, and even then. If you have a system that is designed with user participation, that will end up echoing in a lot of subtle ways through the way you talk about things, the way features are introduced, the way the entire process works. And that community trust is often critical for adoption. And remember, the entire point of this process is to improve security outcomes. So if you're going to build a security tool that no one's going to use because you didn't bother gaining the trust of the community during the development process, you have wasted all of your time. If you have users involved up front, this lets you short-circuit long development processes. An interesting example for this, there's now the Joint Interagency Field Experimentation, which is a US DoD thing where they get people together and they take early prototypes of kit that they think they're going to ship in different contexts. I've interacted with it in the humanitarian assistance world. And they go out into this abandoned Air National Guard base and they try stuff. And they try it when it's still an early prototype, and they try it with engineers and with people who are going to use it in the ground for real. And they find out things like, oh, this radio doesn't work with this battery pack system. Instead of buying 150,000 units and shipping them around the world to a conflict region and then plugging them in and finding, oh, this radio doesn't work with this battery pack. Well, I guess that was, $35 million we just burnt. We don't normally deal in software with development cycles that are that long or that expensive, although sometimes we do. The earlier you can get people in the loop, the faster your iteration speed is, even just versus kind of more traditional design processes. Blended countermeasures are another really interesting thing. This is basically getting us out of that digital security as a digital thing. Computer security is about computers. This is the place where we start looking at how we build countermeasures that combine cultural aspects and workflow aspects and digital aspects and build that support. And it's really difficult to do unless you've got people in the room. And the last one is minimizing team ego. So one of the fundamental notions of participatory design is that it completely centers the user and what the user's goals are. And I joke sometimes, you can either, if you're trying to develop secure systems for high-risk users, you can either kill your ego or your users. The issue is that basically, as long as you are focused more on what your product is going to do, as long as you're focused more on the things that you're going to build rather than the things that your users need and those goals, you are going to end up, saying, oh, our user thinks this, but they're wrong and they should do it this other way. And you're not going to do that analysis to understand why that doesn't work. Any process that convinces you to spend less time thinking about you and more time thinking about your user is going to result in better security outcomes. So, I don't know how many of you have tried to deal with process change for real. It's a complete nightmare. Here are some practical hints that I've found work at least some of the time. So find the people who are doing the other parts of early product design, right? Because what you're trying to do is basically jump forward, several steps. We normally engage, like, if we're really lucky, we get to engage at architectural design. Often, we're down here. We're down at testing. Somebody's built some software, and they say, hey, come and test if this is secure. We're now trying to jump all the way up to like requirements analysis. That's normally where the business analysts are sitting. Maybe where some of the UX guys are sitting, depending on if you're kind of more product team or more enterprise team. Find those guys. Insist on going to all of their meetings. Maybe not all of them, but just start showing up at their meetings and listening, right? Learn their language and their processes. It will be very painful. I'm not going to say that it's not going to be, but if you do that, then when you push back and you say, okay, there's a security implication here, or there's an opportunity here to do something that will improve user security, you can tell them what they're what you want to do and what you care about in a way that they're actually going to understand. The security community is terrible about this. We insist that everyone adapts to our language and our process. And sometimes there are good reasons for that, and sometimes it's just, well, we have all the bugs and we'll make your company's life hell if you don't adapt to our process. This maybe it's justified, maybe it isn't, but for this kind of stuff, if you want people to let you into that early design process that you can actually improve security outcomes, you don't get to do that. Walk through that design life cycle carefully. Give yourself room to fail if you can, and this is always difficult for team efforts where you're expected to kind of show ROI and everything else. It's one of the reasons why I encourage, if you're trying to build a security design effort, don't get permission to start with. Just start showing up to things. It gives you that much more buffer before you have to actually be accountable and prove ROI. And there is not a lot of existing knowledge and existing understanding on how we structure this stuff, right? The security design process is not well understood yet. It is not something that is deployed at scale in really any dev shops for real. We're still struggling to even get threat modeling done. How many people here have built a threat model for real? 1, 2. I'm gonna jump in and do an ad hoc. This is why and how you should threat model, because I forget that despite it being 2015 and the fact that threat models were in theory kind of yesterday's news in 2004, everybody has forgotten about them or forgotten to start doing them. So a threat model is how you define, coherently what security is. So it's the thing that, it's the carrier for your security design. It's the carrier for the requirements for security for a system. It is how you communicate those requirements. It's how you show that you've finished your analysis. So a good threat model is, I'm going to actually pull up another slide deck. No, I'm not. Never mind. A good threat model shows you when you're done. And so this is one of the problems that we often have when we're doing security architecture analysis. Security architecture analysis often is we get a bunch of hopefully smart people and they sit around a room together and we try to figure out how an application might break. And when everybody's bored or the beer runs out, we assume that we found all the potential ways it can fail. This doesn't work. So the idea of a threat model, a good threat model, you build a model of the requirements and a model of the architecture that are separate and are formal, not in the like Z code provability sense, but in the sense that you can actually say, have we understood all of the ways that the parts of this system can interact? Have we understood all of the ways that this system can break and can go wrong? At a high enough level and with enough formality that we can actually then say plan tests from that. Tell developers, this is the list of things that you need to build to. A good threat model is a lot of your security specification and security requirements documentation. How many people here have interacted with security requirements documentation in systems at all? Okay, a few more, not that many more. That's terrifying. If you ship a system and it doesn't have security requirements, it's broken fundamentally, because that means that you do not know you do not know whether it meets its security requirements. It doesn't have any security requirements, so therefore it cannot be secure. You have no way of telling whether or not it's secure. There's a lot of work in the development process that we end up skipping when we focus entirely on the low level, entirely on the testing. The idea that finding bugs in a system is meaningful is really kind of, is a meaningful indicator of whether or not it's secure. Doesn't really tell us anything. If you know that you found a bug, that's great, but it doesn't tell you how many more might be there. So if you don't have security requirements, you're screwed. You have no way of developing to them. The threat model should be the thing that's driving that. Start building threat models first. If you're not building threat models for every piece of code you write, or every piece of code that your org writes, you're not ready to do security design yet. Once you are at that point, and once you have a more mature process, this is when you can start thinking about whether or not you are actually supporting the things that your users are trying to do. So I'm going to go ahead and jump to questions. I've got more stuff that I can talk about, but I know that I'm kind of a good ways from where a lot of the content in this at this conference has been, and I think that would be more useful. So.
Are there any questions? I guess you had a quite clear story then. Thank you very much, Eleanor.